Hello everyone. Today we are going to talk about Singleton design pattern. As the name suggests, we have a class called as Singleton, and at any given point in time you can get only one instance or one reference of that Singleton class. So in this example that you can see here, we have a Singleton class which holds a file. Now my application wants to log some error, and to do that it is going to ask the Singleton class to give a reference so that it can write into the log file. So when my application wants to write a error log called as error1, what it is supposed to do is it is going to ask the Singleton class to open the file for the application so that he can write the error1 over there. Then my application wants to write error2, so it asks for the reference and it is essentially going to get the same reference and it is going to write into the same log file. And when it wants to write log3, it is going to ask the Singleton class to give a reference which is connecting to the same log file so that it can write the error3 over there. Now let's try to jump in for the implementation. Let's write some code in C++ to implement the Singleton design pattern. So this is my application that I was talking about. So look at this application. What it does is it is trying to create a reference, and what it is going to do is it is going to write into the log file. So it is essentially going to write error1, error2, error3 over here. So let's try to see how we can implement this pattern. Let's try to go into the logger.h, which essentially is the Singleton class that we need. So if you look at this class, there's some interesting things that you can notice. You can see we are having this logger constructor which is put into private. The reason for doing this is we want the application, the client application, to create only the instance of this logger class via the instance API that we have. It can never use the constructor to create an instance. So let me just show you that. Let me try to create an object of logger class just by using the new operator. So let me show you that. Okay. So here if you see, what it says is inaccessible. That means this particular class is restricted to create any object via the default constructor. So that is what we have achieved by just making this constructor as private. Now let's look at the public data members as well. We'll start from the bottom. Let's look at another constructor that we have here called as copy constructor. So what we have done is we have removed the default copy constructor that is given by the class logger. Why we did that? Let's go to the client application to understand that. So when you are writing logger4 equals to logger1, what it is going to do is it is going to do a swallow copy of logger1 and put it into logger4. Let me just uncomment this to show you that. Now what happens here is, since you have added it as delete, what will happen, you will not be able to create logger4, and that's what the error also says. If you look at the error, it says cannot be referenced, it is a deleted function. Now we have done that just by adding a delete keyword over here. Now look at what we have done over here. So here what we have done is we have restricted the application to use the assignment operator to copy one object to other. So that's why we have given delete over here. Let's go ahead to our application to see that. Here I have an existing object logger2 and I have an existing object called logger1. I want to copy the content of logger1 to logger2. Obviously this will also do a swallow copy. Let's try to uncomment this and see what happens. So if you look at this, you are going to get the same error, cannot be referenced. It is a deleted function. So this is what we have achieved by basically adding a delete over the default assignment operator that we have. Now let's try to go to the method called as instance. Now this instance API is having some syntax, as you can see over here. What it does is it is just creating a static member here, static variable here, and it is just returning the variable. So the reason why we want to make it a static, because we want to hold only one instance of this logger class at any given point in time, and then we are just returning the same instance. And this is the implementation that you are seeing over here is inspired by the C++11. If you are using some of the older implementations with reference to C++98 or even before that, you don't have this kind of syntax. Rather, what you can do is you can rather use the normal data member with a static logger instance, a reference or a pointer, and you can return that. But the challenge that you will have there is you need to have some synchronization mechanism, because by default nobody is going to help you with the thread synchronization. So you need to write some synchronization logic either through mutex or through any other means. Now let's look at the other API called as log error into file. So this is going to do nothing apart from writing the log that you are sending here to the log file that we have placed in c:/cpp log.txt. So what it is going to do, it is just going to append. Let me just take you through the debugging also. So let's try to debug this code to understand what it is going to do when we are trying to ask for a reference of the Singleton class. So let me put my debugger on. Okay, so let's start the debugging now. I am at line number 7 and my intent is to create an instance of logger class. Logger is my Singleton class. So let me just go inside the instance method. I am going to press F11 to go inside, and I am going to create a logger instance here and return the same instance. Just notice the address that we are getting here. So you can see here the address that we are getting here is ending with A540. So why I'm telling to notice this, because whenever we ask this Singleton class to give a reference, we'll always get the same reference. So we're going to get the same address which is ending with A540. Let me get inside the log error into file method by pressing F11. Now what I'm going to do is I'm going to open a stream file here and I'm going to append. So whatever I have sent is error 1 and I'm going to write it, and then I'm going to close the file that I have opened, pressing F10 again. Now I'm going to get inside the instance method again, and yeah, we are going to return from here. The magic happens over here. You can see here, whenever I asked for another reference, I got the same reference which is ending with A540. Let me just press F10 again, and I have a breakpoint set into log error into file. So I directly came inside this. I'm going to press F10, 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 and what I have sent is error 2. So that would have already been written to the file. We'll look at that at the end. And the same thing happens when I'm going to log the error 3. So I'm asking for another instance. For that I'm going to put F11. Yes, I'm going to return the same instance. So here you can see A540, A540, A540. So this is where it confirms that all the references that I have created are nothing but the same reference. Then I am going to press F11 again. I am going to write error 3. Let me just continue. So now we are done with the program. Let's see what happens to the file that you have written. So let's open the file that has been written. So you look at this file, you can see error 1, error 2, error 3 has been written into the same log file. This is all about the singleton design pattern. Thanks for watching this video.